Dear friends, greetings from Total Output Power Solutions. Now in this 210 megawatt simulator, we are today going to roll further and synchronize the TS set to grid. Well, I am Manohar Tatwawadi from Total Output Power Solutions. So we will go further with how to roll further and how to synchronize. Now till what we have achieved till now is the MS pressure is around 30 kg per square centimeter and temperature at around 280 degrees centigrade plus 50 maybe around that, and the turbine speed we have achieved at 500 rpm by means of regulating valve, bypass valves MS5 and MS6. Now all turbovisory readings have been taken and noted. The heavy oil guns are now ready for firing. The auxiliary PRDS steam pressure and temperature is being maintained. We constantly check this. Then boiler drum, deaerator, condenser and DM tank levels are normal. Now all the supplies for the CHP auxiliaries also are to be made ready, as we are going to take the CHP in service immediately after rolling. The rolling after 500 rpm, that is, we are doing it for 210 megawatt LMW machine by BHEL. Now as per the manufacturer of the turbine, the soaking is to be done at 1200 rpm. The speed is to be raised at around 40 to 50 rpm per minute. The critical speeds are at 1585, 1881, 2017 and 2489 rpm. Hence, we are not supposed to stop at these speeds and pass them over quickly. You can observe the eccentricity and vibrations at critical speeds. While raising the speed of the turbine, always observe the drum level, boiler drum level, main steam pressure and the turbovisory, specifically eccentricity and axial shift. The diagram as per the chart that has been supplied by the BHEL, the manufacturer, is for cold rolling is something like this. You can see here the first 500 rpm you have to raise in just 5 minutes. Then there is a soaking time of 10 minutes approximately. This 10 minutes is generally it is for taking turbovisory readings at 500 rpm. Then you can move on from 500 to 1200 rpm in around 20 minutes. Then again we will be soaking the turbine at 1200 rpm for around 10 minutes. It will run continuously on 1200 rpm. The speed rise from 1200 to 3000 rpm, that will be directly we are raising the speed, and we are not stopping at critical speeds. The critical speeds are 1585, 1881, 2017 and 2489. This we are doing it in 10 minutes only. Then synchronize the unit at 3000 rpm within 20 minutes. After getting the speed of 3000, you should synchronize it within 20 minutes. Lesser than that maybe. Keep the 10 megawatt load for about 40 minutes, and till that time make the CHP ready and other things also ready for taking the load further. So let us now start the simulator operations. In this total operations, we are going to take up to 10 megawatt load, and further CHP loading we will be doing it in later videos. So please like, share and subscribe. Total Output Power Solutions, BALEWADI, PUNE. Yes, friends, we have already started rolling, and after stopping at 500 rpm for 10 minutes and taking down the readings, we have rolled the unit further up to 1200 rpm. So we start with the 1200 or from 1200 rpm and further. So we have to open the valve, and as well as we have to open the MS valve, MS5 and 6, and at the same time we have to watch the pressure and temperature of the main steam. So main steam pressure should not go down. If it is going down, we see that it is going down. So we have taken support, means there were 2 guns in service, so we have started 2 more guns in the heavy. So 2 more guns we have started so that the pressure will not come down. Now we go to the turbine control panel, and there we increase the RPM. We want to increase the RPM. We can increase it from the mimic also. MS5 6 can be operated from the mimic. So we open it slightly so that the speed will increase. The pressure just now is 28.56 and we are now increasing the MS5 and 6. So that will increase the uh, RPM. Now you see that the RPM is increasing. It is 13030405 like that, and it must have been explained that the RPM should not be increased such that the it is not beyond 50 per minute, 50 RPM per minute. So below that, that should be the increasing rate of increase in the RPM. At the same time, we will see the check the HPT differential expansions and HPT, IPT, then the turbo speed, CVSM, speeder gear position, eccentricity, all these readings and trends on the trends also and the panel also we are able to see that the differential expansions as well as the axial shift and shaft eccentricity. Now actually the speeds at the critical speeds we have to pass over quickly. Now the speed is 1629 and you can see the 1585 first the critical speed has crossed. So the graph you see the shaft eccentricity has increased and the bearing vibration has also increased at that particular moment. We have to pass this speed very quickly so that the speed is now the same eccentricity, the speed is now 1715, and we are still increasing the speed. Now you can see, you have the same experience in case of the other critical speeds also. We have passed over one critical speed, second critical speed, and this is the second critical speed at which maybe the third critical speed because the already it has crossed the speed. So this is the at the critical speed you will also able to hear the jerks or the maybe the vibration and the eccentricity on the floor also. So on the floor also it will be there and turbine floor. Now we have reached the speed of 2700. At 2800 speed the starting oil pump which is running at 15 amperes, the you will see when the speed reaches 2800 and more than that, that amperes will come down to below it was 15, now it has come down to 13.5 as the speed has reached 2869.9. So also can be observed. This also can be observed. The shaft eccentricity and bearing vibrations, they are also slightly more increasing, so you have to keep a close watch on that. Now the speed is 2900 and the opening of the MS5 and 6 is around 25%. So we have opened the MS5 and 6 around 25%. Now you see at this time the CVSM is full open. It is 300 CVSM is 300 mm. Now you will see when the speed goes well, the CVSM now is 300 mm as you are seeing. As the speed will approach 3000 it will take command and you see we are raising the MS56 further. The speed is quietly rising. After it reaches 3000 RPM the CVSM will come down. Now here we see in the eccentricity the one more critical speed has been crossed. Now we again open MS5 and 6 so that the speed goes on increasing again. It is around 29% and you will see that the speed has crossed around 3000. We go to the panel again and see. No, it is still 2954 like that. Now once the speed goes beyond 3000, the CVSM takes over and you can see it in the mimic also that the control valves have also started shutting down. Now the speed is still not reached 3000 and the CVSM is still 300 mm in the now the speed, turbine speed is, you see here 3008, and you see here the CVSM is slightly reduced from 300 to 288 or so. Now here also in the mimic also you are able to see that. Now when the CVSM takes over the control of speed, that is on 3000, we are then opening the MS5 and 6 fully. So we open MS5 and 6, and then we open MS1 and 2. So now we will be opening MS1 and 2. So now you see the speed is 3031 or so, and the CVSM is only 148. Now at this stage we open MS1 and 2. So we open MS1 and 2, we put it on the interlock, we open and then again put it on interlock. Now here there has been a mistake. Here you should have opened MS2 also, but here you are closing MS5 6. That should not happen. So first of all MS1 and 2 should be opened, and then only the MS56 can be closed. So now the MS56 has been closed, and the main steam flow is now through the main steam line wall MS1 and MS2 into the HPT, IPT, and through CV, and CV is controlling the speed. You see this speed has come down to 3007, and the CVSM is 141, 142. It is maintaining that speed. Now we go to the generator panel, and in the generator panel we first of all make the field breaker on. So first of all we will make the field breaker on. You see that indication will also appear there that the field breaker is on. Now we will make the field flashing supply on, so that the supply is extended to the field. So we make the field flashing supply on here, and when we make the field flashing supply on, you will see some generating voltage generated. So this is the field flashing breaker. So we are giving the field flashing supply. You see that the generating voltage has started developing generating voltage. So it is 1.1 kV like that, and it will go to around 7 to 8 kV, and then you can manually increase the potentiometer, so that it is still further increased to 15.75. So we are going to increase the grid voltage up to 15.7, and manually. So we are increasing it manually, and now you see that there is a voltage error, that is 9.4. That voltage error, when it is 0, then we can change it to auto AVR, means automatic voltage regulator. We can change it. Now it is on manual, so we are increasing the voltage manually. We are raising the potentiometer so that the voltage is increasing. Now this voltage error, you see it is decreasing. The voltage is decreasing. So the error is decreasing, and the generating voltage, that is increasing. So we are increasing the generating voltage. Now it is 8.9 something and 8.191, and the voltage error, that is decreasing. So the voltage we are increasing here. At the same time, when we are doing this, you can go to the turbine control panel also. There you can check whether the speed is being maintained or not. That is, but generally the speed, once the governor takes over, the speed will be maintained. Now it is 11.279, 11 kV, 11.7, 12 kV. Then here you can see here the generating frequency. The generating frequency is 15.2627, means the speed is around 3000 RPM, 3007 or 8, like that, slightly more than the grid frequency. The grid frequency is also there, it is 50. Now it is 15.7, so the voltage is minus 0.09. So we can put the AVR on auto. So we put the AVR on auto here from this button. We operate this, and you will see that it has in AVR. The Signal will also be there. There will be a red point, red light that will glow that the AVR is on auto. So we have put the AVR on auto. Now you can go to the synchronizing panel. The voltage is there, the frequency is also there, means the generating RPM is the generating frequency is also there, slightly more than the grid frequency. So we can make the synchroscope on at this point, and so we'll go to the synchroscope here. So this is the synchroscope. We will make the synchroscope on. So we make the synchroscope on, and when we make the synchroscope on, you will see that the pointer of the synchroscope will be moving slowly in a clockwise direction, because the speed generating the turbine speed is more than 3000. So it will be slowly moving, and at the same time the generator breaker, we will make it in a position such that giving a command it will be on. So there is a yellow light just above the synchroscope that will show you the synchronizing. If the synchronizing condition is okay, that will glow, that will be red. So when generally at 11:55 the light will be red, so at 11:55 you can close the breaker. Now it is approximately at 9 o'clock position, then 9:10 like that. So at 11:55 you can close the breaker. So now this is, and as soon as you close the breaker you can see the generator megawatt also. So now it is a red light, means you can close the breaker now. So we are closing the breaker. So we have closed the, we have, yes, not yet closed, yes, we have closed the breaker, and you see the generator megawatt, it is started showing generator megawatt. It is 0.362 or something. And here now we will increase the speeder gear a little bit so that the load will be there. We check up here the pressure also. The mainstream pressure is 13.11. So slowly we will just load the generator. We'll load the turbine, and slowly we open the CVSM. Now the CVSM has been opened around fully, and we will now the check up with the, yes, we can make now the synchroscope off as the unit has been synchronized. The field flashing supply also we can make it off, and you will see that the generator RMVA has raised to 7.761. That will be shown in the right hand corner, bottom corner also, or on the, now you can see, check up all the axial shift, eccentricity, and the other thing, the vibrations, etc. Then go to the plant common parameters. There you can see the actual drum level, condenser level, and all this, whether they are correct or not. Now the load has been reached to around 11 megawatt. So we will keep this load for around 15 to 20 minutes, 15 minutes to 20 minutes, and then we will load further. So thank you very much.